How long would it take us to travel 1 light-year? A meditation in the voice of Leonardo Susskind. Last month, NASA confirmed that Voyager 1, the most distant human-made object in history, successfully resumed sending science data to Earth from a distance of more than 24 billion kilometers, a triumph of engineering across nearly half a century of silence and starlight. You probably saw the headline. You probably smiled. What that headline did not tell you is that Voyager, after 48 years of falling outward at 61,000 kilometers per HR, has covered roughly 1/600th of a single light year. The fastest object we have ever built, launched before most of you were born, is still effectively standing on the porch of the house we were born in. The good news is the message you celebrated. The truth is what that message actually means. We are not going anywhere. You use the phrase light year the way you use the word mile. You hear it on television, in films, in casual conversation about distant stars, and your brain quietly files it next to other long distances. A road trip, a flight across an ocean, something difficult but achievable. This is the lie hidden inside the word. A light year is not a long distance. It is a distance so violently disproportionate to human experience that the word itself functions as anesthesia. Let me strip the anesthesia away. Light travels at just under 300,000 kilometers every second. In 1 second, a photon could circle the Earth 7.5 times. In 1 minute, it crosses from the Sun to well past Mercury. In 8 minutes, it reaches your face from 93 million miles away. The warmth on your cheek is already 8 minutes old by the time you feel it. Now hold that speed for a full year, 300,000 kilometers per second, every second, without rest, without slowing, for 31.5 million seconds. The result is roughly 9.46 trillion kilometers. If you shrank the Earth to the size of a tennis ball and placed it in Times Square, the moon would be a marble 4 meters away. The sun would be a hot air balloon in Boston, and the nearest star beyond our own would be another hot air balloon, drifting somewhere over Tokyo. That is 1 light year scaled down. That is what the word you use casually actually means. You have never understood the distance you were naming. Now take Voyager 1, the fastest emissary humanity has ever produced, and do the arithmetic that nobody on television wants to do for you. Voyager has been flying since the 5th of September 1977. It has been falling outward for 48 years. Its current heliocentric velocity, according to NASA's Jet Propulsion Laboratory, is approximately 61,200 kilometers per h-hour, or roughly 17 kilometers per s-econd. In a single day, it travels about 1.47 million kilometers. In a year, it covers around 536 million kilometers. Light covers that same distance in roughly 30 minutes. So Voyager, in 1 full year of flight, covers what light covers in half an hour. To cross 1 full light year at Voyager speed would therefore require approximately 17,720 years. Read that number again, 17,720 years. To go 1 light year. 17,000 years ago, the last ice age was still locking continents under glaciers, a kilometer thick. Mammoths still walked the Siberian plains. Human beings had not yet invented agriculture. There were no cities. There was no writing. There was no wheel. If a Voyager-class probe had been launched at the dawn of human civilization, at the rise of Catalhoyuk, before Sumer, before the pyramids, before language, as we know it, crystallized into anything written, it would still not have completed its first light year. And the nearest star to our sun, Proxima Centauri, sits 4.2465 light years away. So multiply 17,720 by 4.24. The answer is approximately 75,000 years. 75,000 years at the speed of the fastest spacecraft we have ever launched. 75,000 years ago, Homo sapiens had not yet finished migrating out of Africa. Neanderthals still walked Europe. Our species had not painted Lascaux. We had not domesticated a single animal 75,000 years. So the optimists offer the generation ship. Build a vessel large enough to be a small world, fill it with a few thousand humans, and let centuries pass between launch and arrival. This sounds romantic until you do the biology, the sociology, and the physics. Languages drift catastrophically in roughly 500 years. Old English is unreadable to you, and that was only 1,000 years ago. In 75,000 years, the descendants on board would speak nothing recognizable as a human tongue, would remember nothing of Earth except myth, would have no functional concept of the mission their ancestors began. The Roman Empire lasted around 500 years, the Ottoman Empire 600. The longest-lived continuous human institution, the Catholic Church, is roughly 2,000 years old and has fractured, reformed, and nearly collapsed a dozen times. Now ask a sealed metal can of 2,000 people to maintain civic order, genetic diversity, technical competence, and shared purpose for 150 Roman empires stacked end to end. The math of inbreeding requires a minimum viable population of roughly 98 breeding individuals just to avoid collapse, and far more, several thousand, to avoid the slow erosion of the gene pool over millennia. Cosmic radiation outside the Earth's magnetosphere mutates DNA at rates current shielding cannot fully stop. After 20,000 years of exposure, the population would no longer be biologically continuous with the one that departed. In 10,000 years, the ship's culture would be unrecognizable. In 20,000, its language extinct. In 50,000, its memory of Earth would be folklore. A story about a blue world told to children who have never seen a sky. And when their distant descendants, mutated and alien, finally arrived at Proxima Centauri b after 75,000 years of darkness and turned their antenna back toward the place their oldest myths called home, the signal they sent would take another 4 years to arrive. And the Earth that received it, if anything received it at all, would be an Earth 75,000 years older than the one their ancestors left. Every person they had ever been told about would be dust beneath 30 meters of new sediment. So let the optimists dream harder. Give them everything. Give them antimatter engines. Give them fusion torch drives. Give them every theoretical propulsion system on every physicist's whiteboard, all working flawlessly. Accelerate to 1/10 the speed of light, 30,000 kilometers per s-econd, a velocity humanity has not achieved with any object ever, and which would require continuous acceleration of a kind we cannot currently produce or fuel. At 10% of light speed, Proxima Centauri b is still 42 years away. One way, TRAPPIST-1. That small red dwarf with its 7 rocky planets sits 47 light-years from Earth, 407 years, one way at our miracle speed. So choose Proxima. You are an astronaut. You leave at 30. You arrive at 72. You spend 2 years studying a tidally locked world with a sky that never moves, and then you turn around. You arrive home. If the engines hold at 116 years old, which means you do not arrive home at all. Your parents are dead. Your siblings are dead. Your children, if you had any, are old. The Earth you return to has had 4 generations of history you did not witness. Wars you did not fight. Art you did not see. A grandchild who grew up calling someone else's photograph grandmother. And the energy required to accelerate even a small crude vessel to 1/10 the speed of light and decelerate it again is, by conservative estimate, on the order of 1022 joules, comparable to the total annual energy output of all human civilization, burned in a single trip for one ship, for one star. Multiply that by every star you ever wanted to visit. The bill is the heat death of our economy long before the heat death of the universe. And here is the worst part, the part nobody tells you. Voyager 1, the spacecraft you read about last month, the one humanity celebrated for reaching interstellar space, has not actually left the solar system. Not in any meaningful gravitational sense. It has crossed the heliopause, the boundary where the sun's solar wind gives way to the interstellar medium, and that crossing was real and important. But the sun's gravitational influence extends far, far beyond that boundary. Out there, beginning at roughly 2,000 astronomical units and stretching to 100,000 astronomical units, lies the Oort Cloud, a vast spherical shell of icy bodies, the true outer wall of our sun's domain. Its outer edge sits roughly 1.6 light-years from the sun, almost halfway to Proxima Centauri. Voyager 1 will not reach the inner edge of the Oort Cloud for approximately 300 years. It will not exit the outer edge for approximately 30,000 years. 30,000 years inside our own star's gravitational backyard. The fastest thing we have ever built will spend 300 centuries inside the cul-de-sac of our own front door. We did not leave the solar system. We did not even leave the porch. We never left home. We barely reached the mailbox. And this is the answer to the question Enrico Fermi asked over lunch in 1950. Where is everybody? You have heard 100 theories. The dark forest, the great filter, the zoo hypothesis, civilizations destroying themselves, civilizations hiding, civilizations transcending. Listen carefully. None of that is necessary. The sky is silent because the sky is large. If we, with our nuclear reactors and our radio telescopes and our 48 years of Voyager, cannot reach the nearest star in less than 75 millennia, then neither can they. Whatever they are. Every civilization is marooned on its own pale blue dot, separated from every other by gulfs that no biology, no chemistry, no propulsion can bridge within the lifespan of anything that thinks. The galaxy is not empty. The galaxy is an archipelago of unreachable islands, each one staring up at a sky full of lights that none of them will ever touch. The silence of the universe is not a mystery. The silence is the sound of physics doing exactly what physics does. You grew up believing in warp drive. You grew up believing in starships with named captains, in hyperspace corridors lit blue like rivers, in a galaxy you could fall through like a story. You believed the universe was open. You believed that one day, when you were old, humanity would be among the stars. I am not going to lie to you. There is no warp drive. General relativity forbids it without negative energy densities we have never observed and may not exist. There are no wormholes we can stabilize. There is no faster than light travel that does not require breaking the laws by which atoms hold themselves together. There is no generation ship that could survive its own generations. There is no astronaut who can outlive the trip. Every door your childhood opened, physics is quietly closing. Not because physics is cruel, because physics does not care. It is not for us. It is not against us. It simply is. And the great, terrible, beautiful consequence of all of this is that the universe will never come to us and we will never go to it. We are here. We were always going to be here. Every dream of escape was a dream. The only world your species will ever stand on, the only sky your species will ever breathe under, the only soil where your bones and the bones of everyone you love will ever rest is the one beneath your feet right now. The universe does not care. Earth is the only thing that does. Look up tonight. Look up and understand. Those lights were never an invitation. They were a mirror showing us at last How rare and how small and how precious is the single warm room we were born inside.